Hello guys, welcome back to our course. So in this video, I'm gonna explore with you the mesh analysis. So last time we studied the node voltage method, which is based on basically finding the node voltages using basically or based on Kirchhoff current law. Okay, now we're gonna study another method, which is the mesh analysis, which is basically finding the currents of some branches in the circuit. Okay, it's basically two methods for the same circuit should give the same result. Okay, it's just another method. Sometimes it's called mesh analysis, sometimes it's called mesh current method. Whatever you use, it is the same thing. So, uh, uh, the first method is based on Kirchhoff current method. This one, the mesh analysis, is based on mesh voltage method. Okay, so we're gonna find currents in the branches and find the, apply Kirchhoff voltage law and find the currents. So let's have an example here. This example, which is basically one of the nicest example, that will put your hands on, such kind of method. Okay, the first step we should do is to find first if there is a current source in the circuit, because current sources with the mesh current method might cause some troubles. Okay, we should like deal with it in a certain way. So luckily, this circuit doesn't have any current source. In the next video, we're gonna see how to deal with a circuit with a current source. But this one doesn't have one. Okay, and that's basically will make the problem very easy for us to solve. Okay, so the second step is to assign for each mesh in the circuit, okay, a current. Okay, just bear with me. I'm gonna explain what I meant by such, currents. So, what we're gonna do is assign currents and assign them in the same rotation or same direction. So, if you assign that the current is flowing counterclockwise or clockwise, make all this the assumption for all other currents in the meshes. Okay. So, what is a mesh? A mesh is, a loop that doesn't contain any meshes in it. Okay, so this one here is a mesh. So I'm gonna assign a current to it. Let's call it I1. This loop here is also a mesh. It doesn't contain any inner meshes, so it's basically a mesh, and we can assign a current for it. And finally, this one also is a mesh, so we can assign a current for it. Okay. Just as a side note here, what is the difference between a mesh and a loop? A loop can be, it doesn't have this restriction that it cannot contain a mesh inside. So, for example, let's do this with green. So, this one here, that's a loop. But remember, this loop contains like 3 meshes, right? This is also a loop. Let's make it with another color, like blue. This is also a loop, okay? And it contains 2 meshes, okay? But we search here for meshes only. In the next videos, there will be some tweaks for that. But if your circuit doesn't have a current source, straightforward, okay? Find the meshes. Okay, we name this loop here, the first one on the right-hand side, I1, or we name its current as I1. We name the second one I2, then I3. So where is basically I1, I2, I3? Okay, so I1 will be the current that flows in a branch that is not common or not shared with any other mesh. Okay, so the first mesh here on the left, I'm sorry, basically I1 is flowing in that branch in here, because this branch that contains the battery is not shared with any other mesh. This branch is here, in the second mesh that contains the resistance 2 ohm is the one that I2 is basically flowing in. And this branch here that contains the resistance 4 ohms is the one in which I3 is flowing in. Okay? This is basically its actual, branch. So how about, for example, the resistance 2 and the resistance 4 here and the resistance 4 here? Okay? These ones has like shared current, the current flowing in these like shared branches basically will be like a combination of I1 and I2 or I1 and I3 or I2 and I3. Okay? So the resistance 2 ohm here, for example, has a current. This current would be a combination between I1 and I2 because it's shared between I1 mesh and I2 mesh. The resistance 4 ohm here will have a shared current or a combination of current between I3 and I1. And finally, this one here has also a current which is like a combination between I2 and I3. We're gonna find out how to find them. Don't worry about that. So let's just Control Z here and go back to our solution. Okay, so we assigned now, a current for each mesh. We found the mesh and we assign a currents for them and all of them in the same direction here clockwise. Now we should apply KVL, Kirchhoff voltage law. So applying Kirchhoff voltage law. Some people call it Kirchhoff, I don't like this, so I'm gonna call him Kirchhoff. So let's apply KVL here, okay? Just like what we did before in our basics when we learn about Kirchhoff voltage law, we're gonna apply exactly the same, okay? So we find the voltage directions in each branch. So let's use like this current in here. I'm sorry, this color in here. So the voltage direction of the battery is in this way. Okay. The resistance 6 ohm has a current flowing in that way. So the voltage should be the opposite. So this is the voltage of the 6 ohm. Now for 2 ohm, now we are talking about the first loop, the loop, I'm sorry, the mesh of I1. So for the 2 ohm here, this resistance in here, it has I1 flowing in that direction and I2 in the opposite direction. So its current is I1 minus I2. Okay? So I1 minus I2. So for I1, it will be, since it's going down, so the voltage will be up. We are talking about I1 mesh here. Now for this resistance here, I1 is flowing in that direction. I3 is flowing in that direction, the opposite one. So it will be I1 minus I3. Okay? And the voltage should be opposite to I1 direction. Okay? So and this is this one here is basically, this direction here is the loop direction or the mesh direction. Okay, so whatever voltage in the same direction will be positive, whatever voltage in the opposite direction will be negative. So 18 volt in the same direction. So this will be positive 18 volt. Okay. Now 6 ohm voltage is opposite, and so it's minus, and the current in 6 ohm is I1, so minus I1 multiplied by 6. The voltage of the 2 ohm is upside like this, so it's also flowing in the opposite direction. Okay, it has opposite direction. If it rotates, it will be like that. Also, the mesh direction is like that, so they are opposite. And its current is I1 minus I2. So minus I1 minus I2 multiplied by 2 ohm. Then we go to the 4 ohm resistance. Its current is I1 minus I3. And again, its voltage is upside like this. So if it rotates, it will be rotating like that, opposite to the direction of the loop. So minus I1 minus I3 multiplied by 4. All of that is equal to 0. Okay, good. So let's put the 18 in a different side, and is all the opposite, all the other terms is another side of the equation, so everything will be positive. So let's say 6i1 plus i1 minus i2 multiplied by 2 plus i1 minus i3 multiplied by 4 equal to 18. Okay, let's simplify it further. So 6i1 plus 2i1 minus 2i2 plus 4i1 minus 4i3 equal to 18. Okay, now let's take common factor i1 as a common factor from some terms, this term, and this term. So i1, we're gonna end up with this i1 multiplied by 6 plus 2 plus 4 minus 2i2. So we take this one also, minus 4i3. We take this term also, equal to 18. And let's, this is the final result of this, and let's take a look at it. So what is 6 plus 2 plus 4? It is basically the summation of all the resistances in the I1 mesh. Okay? And I1 term is positive. Now, what is 2 multiplied by I2? This is basically this resistance in here. Okay? So the shared resistance will be multiplied by I2, and it has a negative value. And then what is 4? 4i3 here. So this is basically this resistance. And again, it is negative. Equal to 18. 18, what is 18? It is the battery voltage. So if the battery voltage is... So basically, we can construct this equation. This is what I want to say. We can construct this equation just by looking at, systematically, basically, just by looking at, the mesh of I1. So basically, you can just multiply I1 by the summation of all the resistance in its mesh, then subtract other like shared branches. So minus 2i2, minus 4i3, and equal to the battery. The battery will have a positive voltage if it's a voltage in the same direction of the rotation, and in this case it is. It will have negative if it's in opposite direction. Okay. Good. That's for the first mesh. We're gonna do the same, exactly the same for the second mesh. But I'm gonna just follow the rule that we just learned it from mesh I1. So what I'm gonna do for the second mesh here, the mesh of I2, let's first, take, just clean it up. So for mesh I2, okay, I'm gonna write I2 term first. So I2 should be positive because this is the mesh of I2. So I2, and it will be multiplied by the summation of all the resistance contained in that mesh number 2, which is 2 plus 2 plus 4. Then the other terms will be negative, okay, of the shared branches. So we have the shared branches, the shared branch between loop 2, mesh 2 and mesh 1, which is 2 ohm. So minus 2 I1. We have another shared branch, which is the 4 ohm here, between mesh 2 and mesh 3. So it will be minus 4i3. Is there any voltage sources here? No. So equal to 0. This is the second equation. So this is number 1. This is number 2. Now let's do the third one with another color. Okay. So for mesh 3 now, I'm gonna also write the term of I3 first. So I3 multiplied by the summation of all the resistance connected to I3, which is 4 plus 4 plus 4. Then the shared branches. So we have the shared branch between I3 and I1 has a 4 ohm resistance, which is this one. So minus 4 I1. The shared branch between I3 and I2 is this one, the 4 resistance, is a 4 ohm resistance. So the minus 4 I2. Is there any voltage sources in this loop? No. So equal to 0. And this is equation number 3. If you have two meshes that doesn't contain like a common branch between them, a shared branch between them, then the resistance, you can consider it 0. And for example, let's assume there is a mesh number 4, which has no shared resistance with mesh 3, for example. So it will be minus 0I4. Okay, something like that. But we don't have here. That's good. Now we have 3 equations in 3 unknowns. What are our unknowns? I1, I2, I3. And we have 3 equations. Okay, so let's solve it. So we learned that we use, just to review my previous video, in Desmos calculator. It's online calculator. It's free to use. I already solved this before. So I'm going to just show you the solution here. So first, I entered basically the matrix that contains the 3 by 3 equation without the right hand side. So you don't need to calculate 6 plus 4 plus 2. So the 6 plus 4 plus 2 is basically the coefficient of I1. Let's go back to our own note to show you this. Look, 6 plus 2 plus 4 minus 2I2. So we go back, minus 2I2, then minus 4I3. And in another matrix called B, we're going to put the 18. Okay, I'm going to also review the second row here. So minus 2I1, this is the second equation, minus 2I1. Then the coefficient of I2 is 2 plus 2 plus 4. Here it is, 2 plus 2 plus 4, plus 4. Then minus 4I3, minus 4I3 equal to 0. And here is the 0 in here. And I'm 0. And the same for the row 3. Then you multiply them together. You're going to get 2, 1, 1. That means I1 is 2 amperes, I2 is equal to 1 ampere, and I3 is equal to 1 ampere. So let's write this down as our solution here. So I1 equal to 2 amperes, I2 is equal to 1 ampere, I3 is equal to 1 ampere. Okay? So now we know for sure that there is like 2 ampere flowing in that branch, 1 ampere is flowing in that branch, 1 ampere is flowing in that branch. Now we can calculate anything in the circuit. We solved it basically. Let's, for example, calculate the current flowing in this resistance here. Okay, so this is I1, remember, which is 2 amperes, which is going into the node, this node here. And we have 1 ampere coming out of the node here. And let's assume the current is flowing downward. So you have 2 currents going out and 1 current going in. So 2 equal to 1 plus, let's call it I, for example. So we have 2 going in, 1 going out, and this is I. So 2 is equal to 1 plus I. So I is equal to 1 ampere as well. Okay, finally, let's calculate also the current flowing here. Let's call it I dash. So you have 1 ampere going into, I dash going into, and 2 going out. So let's draw it again here. 1 ampere going into, I dash going into, and 2 going out. So what is going out, which is 2, equal to I dash, which is going in, plus 1. So again, I dash is equal to 1 ampere. Okay, guys, that was it. Thank you very much, and see you in another video. Bye-bye.